So this is basically our topic is for the research is Pos-Augmented Statistical Parsing Framework using Tree-Adjoining Grammar for Natural Language Processing. These are the authors. Our area of work is natural language processing, machine translation, and basically Tree-Adjoining grammar. So this is the structure of the presentation, background and motivation, introduction, research development environment, our experiment with tree banks, future scope and conclusion. And there's a literature survey also we have done. So we basically our research basically focused on the advancing NLP through the improved parsing technique, multilingual model, adaptable for the NLP systems. These our objective is the innovation. Through our innovation, we aims to fill our gaps in language resources, enhance the machine translation quality, and provide the powerful tools for NLP research. As a part of our research, we have actually already developed multilingual tag parser, statistical parser we have already developed, and bidirectional tag parser. And these are the research. Last 2-3 years, we have presented like 8 to 10 research paper on different areas. Our fundamental research is based on the basically Tree-Adjoining grammar that is introduced by Dr. Arvind Joshi 1975. Then we have eventually enhanced this model and through the different kind of models and parsers. So basically, I would like to introduce the parser. Parser basically a simple program that analyzes the human language, extract the meaning of the structure of the language, and support various NLP applications. These are the applications like information retrieval, sentimental analysis, machine translation, also speech and QR system like question answering system. And Tree-Adjoining grammar is basically powerful grammatical formulae for processing large scale grammars. So basically, what are the cause for going to the research for tag? While traditional tag is powerful, but there's some limitation to handling the complexity and nuances of the natural languages. We have analyzed various Indian languages. Also, we have done the English and European languages, and we come up with our research like there's a nuances of the language that parser is not currently able to uh, uh, handle these. So traditional models is basically top down and bottom up approach, left to right. This is the parsing process. So early tag parser faced the insufficiency due to computational complexity and memory uses. Now even we improve the memory and improve the computational infra, then parser are very difficult to capture the statistical and dependency between the structure of the source sentences. So basically this paper present the novel probabilistic parsing framework for Tree-Adjoining grammar, and that integrate the part of speech information with the lexical item during the parsing. So basically, tag parser predominantly relies on the lexical information, limiting their ability to resolve the structural ambiguity. So basically, earlier parser based on the lexical items, like any sentences, these are different lexical item, but given the part of speech tagging to these lexical item, these information we can use during the parsing process. So basically, these are the already I have told the key challenges of statistical lexical ambiguity, and part of speech tag considerably reduce the ambiguity while limiting the range of the alternative grammatical representation. The one word in English or any other language, one lexical item can represent different meaning in one sentences. So we apply basically Pos-Augmented Statistical Parser to facilitate the, we have developed the one translation system that is English to Indian language system, and we applied our research on this system basically. So we also train our corpus on the 15,000 sentences, and we have done the empirical evaluation of the across multiple Indian languages through this approach. This is which we are going to cover in later section of the presentation. So basically this is the basic our workflow, where we come to the raw sentences, we tokenize the sentence, we given the tag post tag annotation of the sentence, and this tag set we have the this basically pipeline. We load the elementary trees for each each post tag, and anchoring the tag set with the pause word, and during the parsing this elementary going to select. We extract the pause feature, we surrounding the pause feature with tag, and these are the we capture the sequence and also keep the feature extraction. Condition of the pause tag is to be actually training system also in the this pipeline. We evaluate the training post sentences, we calculate the probability of the each the post text sentence, and after that on the basically we applied this probability during the selection, during the parsing and derivation, and this is basically reduce the ambiguity and parse the source structure. So in this work we adapt the two-step pipeline where the input sentence are processed through the external post tag and generate the token level syntactic annotation, and we assign the post tag to each and every word, and also calculate the probability of